And we're live! All right. Welcome. First hour geometry, your favorite class. The reason for this season, why you even show up to school, let's be honest. All right. Here it is. Today we're doing this review guide, this quiz number 3 review. Can you believe it? This is only our third quiz. It's crazy, right? I think we have more. But we did have a test in there. I've been merciful and not given too many. Although I think you'd rather have lots of them because then they'd be smaller, have less material on them, right? And then if you screw up one, it's not worth as much. So every time you're like, yes, we don't have a quiz today, right? Because I was nice for some reason. Really, you should be mourning the fact that you do not have a quiz. So, like most of the reviews, we're not going to get through all this crap. If you look on the first page, we've got two each of the same thing, right? We've got an example of not linear pair theorem. I don't want to say that. Segment addition postulate here and here. We've also got an example of an algebraic proof. If those are on the quiz, remember not everything is guaranteed to be on there, but if they're on the quiz, those are the ones that you should really knock out of the park, right? Because it's just algebra, and then you have to tell me like addition property, subtraction property, all that jazz. If you turn the page, on page 2, we have 2 examples of angle addition postulate questions. So draw the angle, label the parts, do the thing. Number 5 should look super familiar. 7 and 8 should also look familiar, just with the letters changed and some of the things they give you a little bit different, but similar, right? We're not trying to trip you up here. We're not trying to make you reinvent the wheel. I just want to see, can you actually do these things on your own, right? And since we've done them in class, you've had them for homework over multiple nights, this is like the 3rd time you've seen them now, so hopefully you can. Turn the page again. Again, more familiar stuff. Your favorite diagrams, right? Stuff we've been working on. And then if you get to the last page, well, it's literally this guy, except with all the parts actually labeled correctly. I changed up some of the numbers here and some of the wordings of the questions. For instance, it says that you need to prove 1 and 2 supplementary and 2 and 4 supplementary first, and then prove this, which is fine because if you remember, we got that for free on our way to the last bit, right? You're going to be doing a lot of bi-similar logic on this one to save yourself some time. If I were a betting person, and I am, I bet on the St. Louis Blues to win the Stanley Cup last year in December when they were the last place team. I made a lot of money because they actually ended up winning. What are the odds? They're like the Cubs of the NHL, right? But no longer. Actually, I guess they are because they have won a championship in their history now. So I guess they really are the Cubs. But anyway, if I was a betting man, and I am, I would bet that number 11 is going to be on there. Why? Because it has so much good stuff in it. That's why. Very nutritious. So, first hour. Anyone on the first page you want to do, or you want to come back to them? All right. Turn the page. 5 or 6. Courtney says 5.
Actually, I meant 11.
She meant 11, but how about 5 or 6? You want to come back to them? 5, definitely 5. Okay, that's fair. I guess if we wanted, we could start at like the back of the packet because those are usually the harder ones, and then work our way from there. But such is life. So here's what we're gonna do. We're gonna zoom, zoom, zoom. There we are. So it says D is in the interior of angle ABC. So they give us an angle. This is what's given. Really, it's just a diagram we're gonna have to draw. So we're given this. We have an angle ABC. I'm gonna draw it like that because that's just how I interpret this angle. I feel like giving myself more room to work is always good, so drawing an obtuse angle is good, even if it's not really obtuse. Oh, look, it is 165. Wow. Wow. I'm so good. D is in the interior, so that's here. I wonder if interior is always defined as being within the smaller angle. See how we could have like this be the interior and have it be a reflex angle, right? I would assume interior is always the smaller angle because I've never seen it specified. All right, so ABCD, like that. They tell us ABC is 165. What color, Riley, would you like ABC to be? Pink. Pink. All right, so this whole thing is 165. I think color really helps with this. That way you don't think that this guy's 165, right? Color is nice. I would encourage you to get a set of pens like these. These are the G2 Pilots. So sponsor me, Pilot. G2 Pilots, you can see it says 07 at the top. O7s are a little bit thicker than O5s, right? Extra C, I suppose. And the O7s feel like writing with like lighting. It like glides across the page, and it's beautiful. If that's too thick for you, right? You're not as body positive as I am. You can always go with the O5s. The O5s are cheaper, but they feel like writing with knives. Is what I think they feel like. So, for example, there's the O5. Here's an O7 of the same color, right? One's thicker than the other. One feels like writing on it with a knife. These are the ones I grade with because they're a lot cheaper and easier to buy in bulk. If you buy these guys, which come in color, you can get all those colored pens for like 17 bucks. So not a bad deal, and it'll last you the whole year probably. Won't last me the whole year. It'll last me about like 3 weeks, and then I have to buy a whole new set because you guys take all of my color out of my life. All right, so what color would you like angle ABD to be? Yeah. Blue. Okay, well, we have choices. The lighter one, okay. ABD is this angle. And they say that ABD is x over 3 plus 45. Okay, that's cool. What about CBD, as in the oil? Luke. Orange. Oh, man, solid color choice. I think you guys are getting used to what's available. No one really chooses maroon. Would this be maroon? Burgundy? Chartreuse? Chartreuse? All right, CBD is 3x plus 20. Yeah, please leave a comment for what color this pen is. Please help me. I've had this for years and don't know what to call it. All right, so using all that information, we're trying to prove that ABD is Shrifty 5. Now you remember this problem. All right, so if you're interested, go on YouTube and type in Shrifty 5, and that will get you a video that existed before YouTube and then was later uploaded. It is older than all of you, I'm sure. All right, so this thing. How are we going to solve for ABD? ABD, remember, is ABD. It's the blue one. Any idea? Not a single idea. Laney. I'll take whatever you got.
ABD or ABC minus DBC equals ABD.
Yeah, she's right. So check it out. The whole thing minus the orange part is going to get us what's left over. And what's left over? The blue part, the thing we need, right? So that's cool. That's fine. If that's how you see it, that's great. Now, technically, that's angle addition postulate is what she's doing. She's saying, hey, look, the two little pieces add up to the big one. She's just rearranging the equation ahead of time. I believe in you. I never gave up hope. I didn't even mark you absent. We'll see you, Noah. All right, I got a review guide for you. We're on number 5. Just started. All right. Wow, the whole gang's here. Minus Jenna. YouTube, you should know that because you haven't heard her cough like 5 times by now. All right, so yeah, that's one way of looking at it, saying, look, take the whole thing minus the orange part, we get the blue part. Another way to say the same thing is blue part plus orange part equals this guy, right? It's just rearranging the equation. It's the same dumb crap. So if you see that it's adding and then it adds up to this, right? That's great. That's literally angle addition postulate. If you see it as subtraction, I'm going to skip a step. I will allow it for now. Technically, it's not the letter of the law, but I will allow it. So let's go with Laney's way. Laney says that angle CBD, oh, not CBD, sorry, CBA, the whole dumb thing, minus, and that's the measure, I believe. Yeah, we'll go with measure. Minus the orange part, which she said is CBD, is going to equal the blue part. And that's the angle we're interested in. That's ABD. Pro tip, multiple ways to name this angle, right? We can call it ABD. We can call it DBA. See how they labeled it? I would encourage you to write it the same way they did. That way when you get done, it looks exactly like what they want to see. Right? ABD is one way to call it. The other way is DBA. We couldn't call it angle B because we have lots of angle Bs, right? There's an angle B, there's an angle B. The whole thing's an angle B, right? So make sure you label it the same way they do. That way you don't get confused at the end and get points taken off because it's not exactly right. All right, so here we are. And that's by angle addition postulate, which is kind of weird to call it that because we're doing subtraction. But it makes sense. So angle addition postulate. You could also do AAP if you want. That's the idea. The reason this would be angle addition is because angle addition says these guys add up to this guy, right? And if we move that over by addition property, it would be those two added up equals the pink. So it's all good. She just skipped a step. So now we're here. And I love how you gave me the names of the angles instead of just giving me the amounts, right? Because we can't do that yet, right? We can't start with the amounts. We now need to put those in. So when I plug in these numbers and x values, what do I call that? Substitution. Yeah. So instead of measure of angle CBA, I'm going to write 165 because they are one and the same. If you want to wrap it in parentheses for organization, that works for me. Remember, it's all addition and subtraction, so the parentheses don't mean anything. They're just to show you that you plug something in. Whenever I plug stuff in, I typically wrap it in parentheses. I'm more experienced, though, so sometimes I don't. I would encourage you to, though. It will save you a lot of little mistakes that I later have to fix. All right, so now we're here, and that's by subs, S-U-B-S. Right? And now we just get our x's together and solve. Right? In every step we do, we have to write what we did. So first thing I'm going to do is I'm just going to do some algebra. So I get a therefore symbol, right? I'm just going to put some things together. We've got 165 minus 20. Notice that minus sign distributes. This is why it's good to wrap it in parentheses, right? That minus sign is going to go to the minus 20 like that. Are we seeing that? Again, that's why you want to wrap things in parentheses whenever you plug something in. It'll save you little mistakes. If you just wrote this without parentheses, you might think it's just minus 3x and plus 20, but it's not. The minus goes to both. We're subtracting both of those ideas. Does that make sense? Maybe? Distributed property? Smell what I'm stepping in? Okay, cool. So we have 165 minus 20. That's going to get us 145. And that's a negative 3x on this side. And again, that's just basic algebra. We're just putting stuff together. Let me raise this up. We raise you up. All right. So now we're here. Terrible idea in real life, great idea in math. We're going to get our x's together. I'm going to move the 45 over first by subtraction property and get hundo. SUBT property, right? Subtraction, as opposed to subs. Need to see that T. Let's get it up a little bit more. So now I'm going to get my x's together for real. I'm going to add the 3x to both sides. So that's addition property of equality. It gets us the thing that's already there, plus 3x. So that's by addition property of equality. Now, let's actually get these x's together. Could you have done it all in one step? Sure, you could have. But maybe you're confused because there's a fraction there. Common denominators is what we need. And we're going to get them, okay? But we're going to think of it differently. So what we're going to have is 100 degrees equals, if I've got a third of an x here, the question is how many thirds of x do I have here, right? Well, 1x has how many thirds in it? 3 thirds, right? Right, that makes sense because 3 thirds is 3 over 3, and 3 divided by 3 is 1, right? Checks out. How many thirds would be in 2x then? 6, and so how many thirds are in 3x? 9 thirds, right? And again, if I write that out, 9 thirds, isn't 9 divided by 3, 3? Just another way of looking at it, right? So imagine there's a 9 over 3 next to that x. Well, I've got 1/3 here, right? And if I got 9 thirds there, how many thirds do I have? 10 thirds of x. You could write the x on the side or the x on top, doesn't matter. Does not matter. Just don't write it on the bottom. Now, how do we solve a problem like Maria? Yes? Multiply by 3, that works. So we're going to do multiplication property of equality. And get this. And now the 10 is with the x. Do you see how when we get rid of the 3, the 10 is multiplying with the x, so it's just there? That's why the x on top is fine, right? Because that's all that is. It's 10 times x divided by 3. So now we just have 10 times x left over. That was by the multiplication property, right? We canceled out division. Be careful. Don't call it division, right? You'll get points off for that. And now we're going to use the division property to get rid of that 10, right? Which is going to leave us with 30 degrees equals x. And that's the division property. So we're done, right? What do we need to actually get to? What does it say? Prove ABD is 55, right? So now we got to go back and use that x to prove ABD is 55. I guarantee some of you, maybe even most of you, will stop after this step tomorrow. Don't let that be you. Read the instructions. So ABD, it says here that ABD is the blue part, right? So it's x over 3 plus 45. So we're given, I'm going to write that, given measure of angle ABD She tried to contain it, but it's not working. Yikes. So given this, we can do substitution, right? We get measure of angle ABD equals, let me scoot this up some more, equals, instead of x, we're going to plug in 30, right? And that's by subs, S-U-B-S, substitution. And then we just do math, right? We get that for free. So therefore, measure of angle ABD equals, and maybe you're like, oh man, I don't know what this is. 30 divided by 3 plus 45, that's hard. Well, hopefully you're not, because 30 divided by 3 is 10. 10 plus 45 is 55. But even if if it was difficult, you'd be like, well, I know the answer is supposed to be 55. And if I'm really, really stuck, I could just write down 55, right? If you really don't know what you're doing. Hopefully you do, because we're actually supposed to prove this and not just assume. Eventually we'll be doing proofs, some of them which are not provable. But for now, there's safety. Swag, box, city. How you feel? It's a lot of steps, but you get the gist? Angle addition postulate, substitution, get stuff in, do math, go back and plug it in. Yeah? Same thing for number 6. 7, 8, 9, and 10, I believe. I think we have 11, actually. Yeah, 11. 7 through 11. Which one you got? Which one you want to see? 8? Okay. Feel good about 7? If you don't, remember we did this one in class just with different letters. So you can go watch that on one of the videos. Like and subscribe. Ocho we did as well, but I mean we did all of them in class technically. So let's mark up our diagram. What color? Nah, never mind. Who cares? X, Y is this one, and it's congruent to YZ. They gave us that, right? That's what this is. XV and VU are the same. So here's XV, and here's VU. And remember, we have not been told, as far as we've gone, that X, Y, and XV are the same, right? So if you're doing tick marks and not color, you'd have to do 2 tick marks here, right? We know these two are congruent to themselves, but we don't know the crisscross, right? But then the magic happens here. X, Y, and VU are the same. Oh, so here's X, Y, here's VU. They are the same. So it turns out all of them will be, right? I think you're probably already able to see that that's going to be true. So now we're going to prove it. Shh, Noah. So what are we given? All right, so XY is congruent to YZ. And we're given that XV is congruent to VU. And then we're given that XY is congruent to VU. Again, this is why colors are nice. Because like letters are just mumbo jumbo to me. And we want to prove that YZ and XV are congruent. Now, YZ, we already had a color for. It was blue. And XV was pink. So just so you're aware. Right? That's all we're saying here. So we're given this stuff. Do we have YZ and XV together already? Here's a YZ, right? But no XV. Here's an XV, but no YZ. So they're in separate equations. We need to get them in the same room together, right? So how do we do it? Well, there's no common ground between these two, so this must be the link that links them, right? If there is one. So let's start with one of these. You want to start with the first? Here, I'll number them. You want to start with the first set, the second set, or the third set? Well, really, first or second is your choice. Let's start with the first, yep. So we start with this, and that's given, right? So that's given. Now, how are we going to make that, instead of saying x, y, y, z, we want it to say something with y, z, and x, v. So we need to switch this guy out, right? This guy can stay. This one must go. How do we get rid of that x, y and get it closer to an x, v? Well, if you notice, the only thing we have with x, y in it, other than the one we just used, is this guy, right? So x, y is the same thing as vu. Now, that's helpful because it gets us pink, right? And pink is closer to our answer. It's not what we want, right? We want xv, but it does get us closer. So let's switch it out, right? So instead of writing xy, I'm going to write vu. And I'm allowed to do that because xy is vu. They're the same dumb crap. And when we switch stuff out, we call that what? By what? Substitution, your favorite property. That's right, we should make a song. Great idea, Courtney. All right, so now we're here, which is closer to what we want, right? We got pink and blue in the same room, which is dangerous, I think. So how are we going to switch this guy out for what we really want, which is xv? Yeah, vu is congruent to xv, so they're the same dumb crap, so we switch them out again. So now we switch that guy for xv. Yay! So substitution again. And now we're done, right?
No.
Why not? Yeah, they do need to be flipped, right? They're not the exact same thing. Now, we know forward and backwards is all good, right? But we need to show that, hey, look, we can make it look exactly like that to prove that, hey, there's no doubt. So when we flip these two, what property is that? Symmetric property, not the reflexive, right? Reflexive is A equals A, right? Symmetric says AB and BA are equal to each other. So we do that by symmetric property. And lo and behold, that's what we wanted. Swag box. You're praying that one's on there, right? You're praying it's on there.
Yeah. It's
Questions, comments, concerns other than for my mental stability? Turn the page. 9, 10. Feeling decent about those? Yeah? No, not at all. Lainey, you weren't here yesterday, right? Lainey, I would encourage you to go back and watch the video. I will do one of these for Lainey's sake, though. Lainey, you don't really know which one you would prefer since you don't know either of them. So rest of class, which one would you prefer?
9, 10.
Ooh. Do I listen to Michaela or do I not?
Well, that one looks easy. That looks harder.
They're really the same kind of question. They really are. So here's my argument, Michaela. For 9, we have 3 angles to mess with, and what's going to happen is we're going to show that 1 and 2 are complementary, which means they add up to, sorry. So for number 9, we have 3 angles, right? And we're going to show 1 and 2 are complementary because that's given, right? So that means they add up to 90. Well, we also know 2 and 3 add up to 90 because they're complementary, right? So the middle ground's the 2. So 1 plus 2 equals 90, 2 plus 3 equals 90, so they equal each other, right? 1 and 2 equal 90, 2 and 3 equals 90, so 1 plus 2 should equal 2 plus 3. Subtract the 2's, we win. How do you feel? Okay with that? Yeah? About 50? Okay. It's going to be the same crap as this, except we're going to have more angles to do it with. Okay? And it's supplementary. Number 10, given 1 and 2 are supplementary, 3 and 4 are supplementary, and 2 is congruent to 3, prove that 1 is congruent to 4. Okay, so because I know 2 is congruent to 3, I'm going to try and make them the same color. Lainey, what color would 2 and 3 have to be in your world? Maroon? Do you mean this one? Lainey says it's maroon. If you think she's wrong, leave a comment. 2 and 3 are maroon. And they're congruent, so I'm going to mark that on my diagram that they're congruent. And wherever I see a 2 or a 3, I'm going to color code that. And we need to write that eventually. So I'm going to write this down here, that 2 and 3 are congruent, because that's given, right? Okay. Jerkica, what color is number 1? Pink. Everybody loves pink. Yes, we do. I'm sorry. Yeah, they are not equal. They are congruent. Remember, figures are congruent. Numbers are equal. And we weren't talking about their measure, right? That's what the little m means. Everybody picking up on the little m now? I know for a while you guys were reading like m angle 2. No, dear God. All right. Maybe I should make it more cursive. 4. What color do you want? Courtney! What do you want? Angle 4 is orange. Oh, I missed one, didn't I? All right, cool. So 4 is orange. 1 we said was pink. We know that angle 1 and angle 2 are supplementary. I have to write it just like that. I cannot write that we're given it equals 180, okay? It's not the same thing. I mean, it is by definition, but we have to prove that, right? We have to show it. So angle 1 and angle 2 are sup. I love the pens dropping and being picked up. Everyone's using color. Be still my heart. All right, 3 and 4 are supplementary as well. They're my babies, doing what I do. If you weren't color people before, you are now, and I have had an effect on you. I have scarred you for life, which is really my goal. All right, so that's all the stuff we're given, and we're trying to prove this. 1 and 4 are congruent. Cool, so we need to get 1 and 4 in the same room. Notice we don't have them in the same room currently. Darn, man, it would be an easy proof. So we got to get them in the same room. Notice there's some commonality between these two equations, right? Let's write what we know, though. What does it mean to be supplementary? By definition, what does it mean? Yeah, so the sum of the two angles adds up to 180. Remember, supplementary is a relationship between two angles. It means the relationship is that they add up to 180, right? So let's write that. Measure of angle 1. We'll write it here. Measure of angle 1, which is pink, plus the measure of angle 2 is 180. And we know that by definition, right? That's the definition of supplementary. I don't know the definition off the top of my head. I couldn't define it for you, but I know when I see it, right? They're supplementary. Enough! Measure of angle 3 and measure of angle 4, likewise, are going to add up to 180. And those are both by definition. Those squiggles. You guys have seen the sponge lady, right, with the paint? No, we'll have to watch that one here. All right. So now we're here. What do these things have in common? They both equal 180. Beautiful. Okay, so there's two things they have in common. One, these guys are both the same color because they're congruent, right? So there could be a way to get angle 2 on its own and have angle 2 equals 180 minus the one we moved over. And then we could substitute it down here once we switch that out, but that's a lot of extra work. What would be easier is to say, look, they both equal 180, therefore they equal each other, right? Okay, let's do that. Measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. Look how efficient I'm being. Wow. Fastest writer in the West. And that was by subs, right? We substituted in what used to be 180 over here. We switched out for measure 3, or measure of angle 3 and measure of angle 4. You starting to smell what I'm stepping in with that? Feeling decent? Yeah? Okay. And now, notice if we subtract these two, we win. However, they're not the same thing, so we can't just say they equal 0, even though we know it would be. So what we have to do is switch out one of these. Which one do you want to switch out, the 2 or the 3? The 2. Okay, so instead of writing angle 2, I'm going to write angle 3, right? That's all. So measure of angle 1 plus, not measure of angle 2, we're going to switch that out for measure of angle 3, and we're allowed to do that because they are congruent, equals the measure of angle 3. I'm not being efficient at all. I love the pen dropping noises. And that was by subs as well, right? Yay! We're almost done. What's the last step? Say it. What's the subtract from both? Very good. So when we do that, we get this. Measure of angle 1 equals measure of angle 4. And it's not really our last step, but it's really the last thing we have to justify. We did that by subtraction, S-U-B-T. I swear to God, if you write S-U-B, I'll just mark it wrong. And then we want to show that the figures are congruent, right? Well, we know if the angle measures are congruent, then the figures are congruent. So let's write that. Angle 1, without the measure symbol, is congruent. Little tilde. Angle 4. Swag box. We don't even need to use the symmetric property. Hooray. How do you feel? Dece? Dece. Again, here's what we did. We know they're supplementary, so we wrote what that means by definition. Well, if that's what they are by definition, great, they equal 180, then they both equal each other. And if they both equal each other, we can set them up like that, and then switch out angle 2 for angle 3, subtract them, and we win. It's not as bad as you remember, right? It's better. 11. They say A, B, and C are collinear, and D, B, and F are collinear. All that means is the points are on what? The same line, which means DBF and ABC must be lines. So first, let's write what we're given. Given, which starts with a G every day. Given ABC collinear. Jerica, stop talking in my class. Have I ever actually been really mad at someone in here yet? I don't think I have. I just pretend to be. Today's the day. Shut up, Courtney! All right. Prove that angle 1 and angle 2 are supplementary and 2 and 4 are supplementary. Let's give some colors to our angles. Jerica, what color is angle 1? Blue. Thank you very much. Haha, it's not pink. How about angle 2? Another vote for maroon. Idiots. All right. Noah. Angle 4. That was the greatest thing I've ever heard. First of all, white. That ain't gonna happen. Second of all, blue we just did. Oh, dark blue. Oh! Wow. Thinking outside the box. There it is. Yes. Angle 3? Yeah, why not? You got something to say?
No,
Green? Okay. Wow. Someone's not a fan of my variance and laughs. All right, so here we are. We have all these angles. 1 and 2 are supplementary, 2 and 4 are supplementary. We know that, so let's write that. Angle 1 is blue. Oh, no, that's what we want to prove. Okay, that's what we want to prove. So given this stuff, we know that ABC and DBF are lines. By definition, right? If the points on them are collinear, then the line itself, well, the thing itself is a line, right? Seems really silly, but it is. So now that we know those are lines, I know something about angle 1 and angle 2. What's their relationship, angle 1 and angle 2? They're supplementary. How do we know they're supplementary? Because they're on the same line. And linear pair theorem says if they're on the same line, then they must be supplementary. But we can't use linear pair theorem unless they're a linear pair, right? That's the whole point. Linear pair theorem says if you have a linear pair, then they're supplementary. And if they're supplementary, they add up to 180. How do we know they're a linear pair? Are 1 and 2 a linear pair? Yeah, right? They're linear. They're on the same line. There's 2 of them, right? Pair means 2. So they're a linear pair by definition. So that's what we have to write first. So angle 1, which is light blue. Thank you, Noah. Angle 1 and angle 2 maroon. You're a maroon. Angle 2 are a linear pair. And we know that by def. And if they're a linear pair theorem, which is what I'm going to use next, says they must be what? They must be supplementary, right? We can't say they add up to 180 yet, right? That's the next step. So we know angle 1, angle 2. If you want to save time, you could have just done like little quotations right here to say same dumb stuff as above. Are supplementary, S-U-P-P, and that's by linear pair theorem. Therefore, measure of angle 1 plus measure of angle 2 equal 180, right? By definition, right? That's the definition of supplementary. Now check it out. We wanted to prove 1 and 2 are supplementary. So we did that right here. So a little swag box here. Right? That was one thing we wanted to prove. By similar logic, we also know that 2 and 4 are supplementary. Four is dark blue. Thank you, Noah. Are supplementary. So we get 2 for the price of 1, right? Why can we use by similar logic? Laney wasn't here. Well, imagine if I substituted 1 and 2 for 2 and 4. Right? They're a linear pair, right? So I'd write they're a linear pair. And then I'd say, well, then that means they're supplementary by linear pair theorem. And that means they add up to 180 because that's the definition. So it's saving me time. It's going to be the same argument, just with different angles. Right? So it saves us time. Last thing we need to do is prove that 1 is 4 and 2 is 3. So I've got this for 1 and 2. Let's get 1 is 4. That's what we want to do, right? Prove that 1 is 4. So I need to switch out that 2 for a 4 somehow. So I've got this. 1 and 2 add up to 180. Don't I also know that 2 and 4 add up to 180? By same logic. Didn't I just say that? Okay, cool. Now I'm back to here. So now I know measure of angle 2 plus measure of angle 4 equals 180 by definition. See how that works? Right? I got that these guys are supplementary, just like I got that these guys are supplementary. From that, I concluded that's 180. From this, I concluded that's 180. Smell what I'm stepping in? Okay. Now, the magic. Laney sees this. These guys add up to 180. These guys add up to 180. They must add up to each other, right? Cool. Pretty good for a kid that wasn't here yesterday. All right, so we know that measure of angle 1 plus measure of angle 2 is going to equal measure of angle 2 plus measure of angle 4. Dark blue. And that's by substitution. S-U-B-S. And now I think you see the magic, right? We don't even have to switch out 2 for something else, right? We just subtract 2. It's already the same. And when we do that by the subtraction property, we get measure of angle 1 equals measure of angle 4. That's by S-U-B-S. S-U-B-T. Subtraction. And we wanted to prove 1 is 4, right? So we have to write it as congruent. And luckily, we don't have to do symmetric property. Everybody hates when you have to do that. It's one extra step. Okay, so we get that for free. Therefore symbol. That's a swag box. Now, by similar logic, 2 and 3 are going to be congruent as well. Right? Here's 1 and 4. Here's 2 and 3. Same dumb thing, just switch out the angle. So what we're going to say, by similar logic, angle 2 is congruent to angle 3. Make sure you write it the way they wrote it. They had angle 2 first. And angle 3, I forgot what color it is. Green. Done. Another swag box. 2 for the price 1. It'll be the same dumb argument. You'll go all the way back to the beginning. You'll say, hey, look, 3 and 4 are a linear pair. Hey, look, 1 and 4 are a linear pair. Amazing. Or I'm sorry, not 3 and 4. Let's do, 3 and 4 and 2 and 4 are a linear pair. Therefore, they equal each other. Switch them out. Cut out the middleman. Middleman's 4. 2 and 3 are congruent. It'll be the same dumb argument. How you feel? Like, sort of okay? Like, almost surprisingly okay? But then you're like, but how am I going to do that in the quiz tomorrow? Yeah. Okay. Again, if I was a betting man, and I was, and I'm very good, won a lot of money, on a team that was in last place, I won the Stanley Cup. Yeah. My only regret is I did not bet everything I had. One guy won like $6 million. I did not. I had very little money at the time to spend, and my faith was very little, given that they were the Cubs of the NHL. If only, the woodpecker cries. All right, so I would bet that this is going to be on there. Now, how many different ways can I screw with you to change this up? Not many, right? I can call the angles different numbers. I can switch ABC and make it up here and DBF down there, right? I can call XYZ or something. But in general, it's going to be the same dumb problem, right? Understand the concepts. Make sure you see the flow of what's happening here. And you'll be all right. Don't memorize it. Because as soon as you start memorizing ABC, angle 1, angle 4, all that stuff, I change it up on you and you're screwed, right? Because you never knew what it meant in the first place. Understand the flow. Start out saying they're on a line. And if they're lines, then those angles are a linear pair. If they're a linear pair, then they're supplementary. If they're supplementary, they add up to 180. That's part 1. Same dumb crap for the other two set of angles. Now remember, I chose 1 and 2 and 2 and 4 because they have something in common. Right? I know 1 and 2 are supplementary. I know 3 and 4 are supplementary, but they have nothing in common, right? Make sure you choose a set of angles that has something in common. That way when we subtract them, they go away. Otherwise, you got to switch stuff out. Not fun. Bang, bang, bang. Hopefully, once you get to here, the rest is free, right? So really what you need to do is do this. 1, 2, 3, 4, 5 lines. 6, technically. I believe in you. Knock this one out of the park. Do it. I'm not saying it's easy. I'm saying it's easy enough where if you put a lot of effort into it, it will pay off. So do that. That way you're not having this drag you down. Because in the coming weeks, we're going to be doing more proofs, and it's going to be less of these guys and more of these. And not only that, we'll be writing it out with words, which we have basically done. It's very similar. Are you one of those people that when you write a paper, you write the outline, and the outline is basically the paper? Because that's like me. I can't just like do little bits. That's what this is. It's basically the written form. How I'd write this out is I'd say something like, given that ABC and DBF are collinear, that means that ABC and DBF are lines by definition. Angle 1 and 2, therefore, are a linear pair because that fits the definition of a line, right? And then 1 and 2 are supplementary because that's by linear pair theorem. By the same logic, 2 and 4 must be supplementary, and that means both of these equal 180 by definition. If they're both 180, then I can switch them out and say that they're both the same thing by substitution. And if I subtract angle 2 from both sides with the subtraction property, I get these guys. Therefore, angle 1 and angle 4 are congruent. I don't know. I feel like if you were to read this and explain it to somebody, that would be what you'd write. It's not a whole lot of extra. All right. So, got about a minute. What do I do with myself? This is why I teach bell to bell. I don't know how to interact with people, except talk at them.
Is this homework?
Yeah, it is. So that thing was homework, which should all be correct since we did every single one in class. So go turn that in now. Or keep it until tomorrow and use it to study. Right? Everything's due Friday.
Did you find my test?
I did not look for it yet. What'll happen is I will probably go through all of Friday tomorrow, and if I have any free time where I'm not answering questions like a madman, which I will be, let's be honest, during quizzes, I will look for it. And if I don't do that during school, what'll probably happen is the bell will ring at 3 o'clock. People will go home because you'll be like, I'm tired of this, right? And I will go home and I will sleep for like 14 hours. Then I'll come back Saturday and I will do it. Because that's just my life. Go away! all of you.